Hello everybody, I'm Luigi Rossi, safety engineer and PhD student at SHWA University in Viterbo. Today I will show you some highlights from a review article regarding smart solutions for reducing human-machine interference risks in agriculture. The simultaneous presence of autonomous agricultural vehicles and workers on foot can result in poor interaction between machines and operators. That's why the INAIL, which is the Italian Institute for Insurance Against Accidents at Work, funded a project called Smart Grid, which aims to develop a wireless infrastructure based on passive RFIDs and active Bluetooth BLE devices. Its purpose is the definition of a system which is capable of preventing hazards like runover, contact between workers on foot and tractors equipment, or any contact between workers on foot and the tractor trails or towed equipment. Our first step in the project concerned the identification of any previous practical safety application involving smart devices or any other attempt to safely control an autonomous vehicle in agriculture. So we searched the Scopus database for any of those and we found 68 papers matching our searching criteria. Since the application fields resulted to be very broad, we further refined and selected the ones which helped us to identify particular strengths or weaknesses of a sensor or a wireless network. In this table, you can see the criteria that we choose for the Scopus search. Basically, we wanted to find any wireless application for safety purposes in agriculture and forestry. Great effort has been carried out, although, on any of the sectors we wanted to avoid. Same goes for the applications that are not part of the project, like emergencies or disaster management. This image, which has been generated with the R software package called Bibliometrics, shows the relationship among outdoors keywords, starting from the most used ones in the center. The most interesting feature that we can immediately see is that tractor safety is more linked to emergency notifications or control systems, which are something that most of the time are designed to work in cases of clear danger or accident. On the other hand, we can find IoT devices, artificial intelligence or cameras in association with accident prevention system, which is a completely different approach. This plot might better explain what we have previously seen. It is a matter of innovation that pushes safety to another level. Such newer devices can basically allow us to detect anomalies even when everything seems to be right. And that has a clear impact on research as well. This is the short list of the most important papers of the review. They are important because they describe a particular innovation or let us understand the limits of a particular wireless network. Here we can find the first attempt from Kubota in 1987 to control a tractor with a remote control and some extra automatic features that allowed to perform emergency stops in case of danger, or yet the first attempt to develop an emergency reporting system for rollovers in tractors, which started to show the importance of mobile phones as they are pretty much always present nearby the workers. Or another application, which is pretty much very low cost, from Rino Gubbiani, which integrates a Wiimote, basically a console joypad, in electrical chainsaws to detect anomalies, or a wireless video monitoring system, and yet again machine learning, which is artificial intelligence, which allows to detect the road in an navigation systems for autonomous tractors. Here we can see three images from the previous papers. From 1987, the radio-controlled tractor from Kubota, which is a normal tractor that has been modified with some solenoid valves for acceleration, steering and braking, and an antenna on it for signal transmission. In 2009, this is a device which allows the driver of a tractor to understand if there are any kids nearby the tractor. And from 2013, safe driving is an application for mobile phones which simply detects any tractor rollovers and sends an emergency or report asking for help. From the analysis of the selected papers, we can find three fundamental aspects about safety design. They must be fault tolerant, they absolutely have to perform obstacle avoidance, and they might involve machine learning or any other artificial intelligence algorithm in order to improve the obstacle avoidance, because they can better understand both laser sensor and image processing from cameras. Let's spend now a couple words on emergency notification systems. Mobile phone applications can be of great help because they can send automatic alerts in case of accidents, and they are very reliable, and we can find them basically everywhere because everyone has it, so they don't need to rely on specific devices. Some other safety applications can rely on wireless networks in order to detect hazardous conditions or to reduce the worker's exposure to physical agents like noise and vibration. Even the IoT devices like Internet of Things can be a valuable instrument because they are easy and low cost, so they can use to detect any anomaly. Two are the main issues with such wireless devices, and they are connection issues and the lack of power. Connection issues might be solved in a couple of ways, because you can use aerial systems like drones, because they avoid the biggest trees and can allow to work on larger areas where other networks might fail. Another kind of solution is the use of passive modules or low energy modules, because they don't need any battery or require a small amount of energy. Another solution for larger fields is the Zigbee network, because it's like the wireless Wi-Fi network, but the devices do not require to be all connected to an access point. They can communicate with each other without it. We can draw some conclusions about design, the type of sensors or video capture devices, and wireless networks. About the design, we have to say that in order to operate an agricultural tractor remotely, it's important to develop emergency systems and to allow the tractor to operate in a condition that allows the operator to visually inspect what the vehicle is doing. About the sensors, cameras can provide artificial intelligence, so we can better understand what's going on around the vehicle, but they do not really work fine in bad weather conditions. While lasers, lidars or radars or any other kind of sensor can be combined to obtain an obstacle avoidance system, but they fail, on the other hand, to succeed in what cameras do, so they hardly can provide any understanding of the environment. About the wireless networks, the passive wireless devices represent a reliable low-cost solution, while the Bluetooth offers greater device availability since everyone has a mobile phone with it. Another important feature is the mesh networking, because it can overcome any issues concerning extreme distances from the so-called access point for Wi-Fi networks. Thanks for the attention. I'm here for any question.